Hello there. Okay, welcome back to my video tutorial. The topic of this video tutorial is component method, one of the methods under analytical method. And I'm so happy you are listening now or watching now because this topic will cover huge number of items in your monthly test. That's why I do advise you or encourage you to finish this video tutorial because this video tutorial might help you a lot on studying. Okay, since I happened to give this topic a very real quick last week. Okay, let me just introduce the problem that we are about to calculate the vector resultant. Anna runs 4 meters, 40 degrees north of east. That is the first vector. The second vector is 2 meters going to the east. The third vector, 5.20 meters going 30 degrees south of west. And 60 or 6.5 meters going to the south. Okay, Anna runs that vectors, 4 directions yon. Before stopping for water break, find her resultant displacement where she started. Before we started the computation, I would like to remind you that component method is a good analytical method because it allows you to add vectors which are more than 2. Okay, you can add 3, 4, 5. Okay, that's why I have provided a given which has 4 vectors and we are about to add them up. Okay, the task here is solve for the resultant's magnitude and of course the direction. For the magnitude, we will be using the Pythagorean theorem. If you are still familiar with c squared is equal to the square root of a squared plus b squared. Okay, this formula is from that formula. Okay, just change in some notation or symbols, but the operations are the same. And for the angle, we will be using the formula of arctangent, or most of you are familiar to call it inverse tangent. Okay, and here is the figure of that formula. Okay, for the angle, we will be using tan negative 1. Okay. OA, O means opposite, and A means adjacent. Just remember that SOHCAHTOA. Okay, TOA. Okay, this is the formula. I just simplified the formula, but in your book, it is written in different way, but I prefer to just use symbolism like this for a better understanding. You may turn your book on page 40, sample problem 2.9, wherein it is stated there, Anna runs 4 meters 40 degrees north of east, 2 meters east, 5.20 meters 30 degrees south of west, and 6.5 meters south, before stopping for water break. Find her resultant displacement from where she started. As you can see here, there's a table having 3 columns. The first column is allotted for the given, which are the vectors A, B, C, and D. Okay? You're just going to copy the given on the first column of the table. On the middle column, or the second column, there is the horizontal component of the 4 vectors. And the last column is allotted for the vertical components of the 4 vectors. Okay, let me first discuss the horizontal component or the middle column of the table. Focus on the horizontal component. Okay, when we are talking about horizontal component, there are 2 primary directions that we need to focus on. And these are east and west. Okay, on determining the sign, if it is positive or negative, you are just going to look after the direction of the given vectors. If it is going to the east, okay, it must be positive. And if it is going to the west, it must be negative. For instance, vector A, 4 meters, 40 degrees north of east. Let us just set aside the north direction because we are focusing on the horizontal component. Okay, it is given east. Therefore, it must be positive. Then, the magnitude of the given is 4 meters. Then, cosine 40. Okay? In horizontal component, you will be using cosine. Okay? Next vector, 2 meters going to the east. Since it is going to the east, it must be positive 2. Why there is no cosine? Because there is no given angle for the given vector. Next, the vector C, 5.20, 30 degrees south of west. Since it is going to the west, okay, we are going to use the negative sign. Therefore, it will become negative 5.20, cosine again, then 30 degrees. 30 degrees came from the given itself. Okay, and for the last vector, or vector D, 6.5 meters going to the south. Based from the given, there is no horizontal component. Okay, therefore, it must be equal to 0. Okay. Now, you will be encoding these values to your calculator. Okay, again, just focus on the horizontal component. We will be computing the horizontal component of vector A. Okay, positive 4, or simply 4, cosine 40. Okay, equal sign. It is equal to 3.06 something. Then you should round it off to the nearest hundreds. Therefore, it is just 3.06. Next is the vector B. Since there is no given angle, we don't need to compute that. It will be just 2 meters. Okay. For the vector C, okay, negative 5.20, this is the negative sign, negative 5.20 or 5.2, cosine 30 is equal to, okay, if you happen to arrive with that kind of answer, just press this button and you will be getting the decimal equivalent of that. Negative 4.50, rounded off already. Then, since vector D has no horizontal component, it is just 0. Then we're going to get the summation of the horizontal component by adding the values from different vectors. The first value is 3.06 to be added to 2 plus negative 4.5 plus 0 is equal to, okay, 0.56. Okay, it is positive. Okay, that is the summation of your x value or summation of horizontal component. Now, let us focus now on the vertical component or the last column of your table. Okay, in vertical component, we will be using sine. Okay, then the main focus or the main directions that we must focus on is or are all about north or south. If it is going to the north or the vectors given is going to the north, you're going to use positive. Then if it is going to the south, you will be using negative. Okay. For vector A, 4 meters, 40 degrees north of east. Okay, since it is going to the north, you will be using positive 4 sine 40 or 40 degrees. Okay, if you're going to compute that in your calculator, okay, here is just easy. Just 4 sine 40 is equal to, okay, 2.57, already rounded off to the nearest hundredths. Then for vector B, 2 meters going to the east, since there's no indicated vertical component, okay, you will be just putting it or writing 0. Vector C, 5.20, 30 degrees south of west, since it is going to the south, for its vertical component, you will be using negative. Negative, the magnitude is 5.2 sine, then 30 degrees. Okay. Okay, and that is equal to negative 2.6. Okay, for the last vector, 6.5 going to the south. Since it is just going to the south, we will be using negative 6.5. And there is no given angle, therefore, we will just end at 6.5 or negative 6.5. Okay, just like the horizontal component, we will be getting the summation of the vertical component. Just add them up. 2.57 plus 0 plus negative 2.6, okay, plus negative 6.5 is equal to, okay, just press this, this button in order to express it in decimal numbers. The answer is, or the summation of the vertical component is equal to negative 6.53. Okay. Since we have calculated the summation of the horizontal and vertical components, okay, we will be using the two formulas, the Pythagorean theorem and the arctangent formula. Okay, but before that, okay, I will be flashing a picture or a photo on how I drew the summation of my horizontal and vertical component. Okay, as you can see, since 0.56 is the summation of my horizontal component, since it is positive, okay, I go westward or eastward, eastward. Okay, then at the head of my first vector, okay, I drew negative 6.53. It means to say, since it is negative, it is going to the south. Okay, measure 6.53. And the straight line there serves as my resultant. Okay. Okay, we will be using the Pythagorean theorem or the formula from the Pythagorean theorem, wherein we should get the summation of x, then square it, summation of y, square it, okay, then get the square root of them all. Okay, how to do that? Okay, the answer is square root of 0.56 squared plus square root of negative 6.53. Okay, we will be getting 6.55. Okay, though in your book it is indicated that it is 6.6, we must write our final answer on the same page. Okay, and it must be always rounded off to the nearest hundredths. Okay, it means to say we will be using the 2 decimal numbers. Okay. Okay, for the direction of the resultant, okay, based from my previous video or the topic that I tackled earlier, okay, in order to get the angle of the resultant, we will be using the arctangent formula, wherein angle is equal to tan negative 1 or inverse tan, okay, then the absolute value of the opposite side over the adjacent side. Okay, go back to our illustration earlier. Okay, this is the angle that we are looking for. Okay? So you can see, angle is indicated there. And the opposite side of that angle, the angle of our resultant, the opposite side of that is, okay, the y direction, or the summation of our y, okay, which is equal to negative 6.53. And the adjacent side of our angle is equal to 0.56. Therefore, in order to get the angle, we will just encode it in our calculator. Since we are using tan negative 1, okay, you just need to press shift, then tan, okay, tan negative 1. Then the opposite side is equal to 6.53 since we are using the absolute value. Therefore, don't include sign. Divided by 0.56 is equal to 85.09. Since it is an angle, okay, it is, or we will be just using the whole number. Okay, the final answer of our resultant will become, just mix the answer from your Pythagorean theorem and from the arctangent formula. For its magnitude, we will be getting 6.55 meters. And for its angle, or comma, 85 degrees. Okay, determine the direction through looking at the illustration. Okay, the direction is south of east. Okay, I will just repeat, 6.55 meters, comma, 85 degrees south of east. And that's all for the component method.